In this lesson, we are going to talk about polynomials. We will learn how to define and identify polynomials, classify polynomials by degree and number of terms. We will learn all operations with polynomials, add and subtract, multiply and divide. Now, the word poly means many, and the word nomial either means part or terms. So let's define what a polynomial is. Polynomial is an expression containing one or more terms in which all variables have whole number exponents and no variable is in the denominator. So in this chart below, we're going to take a look at some examples of polynomials and compare them to the non-example. So you may want to write this chart in your notes. So our first example and non-example, they look very similar. The square root of 3 times x is a polynomial because x is not part of the radicand. However, you cannot have a variable as part of your radical expression because really this could be rewritten as the square root of 3 times x to the 1/2. And remember, your variable cannot have an exponent except a whole number to be a polynomial. Our second example, 3x squared, polynomial, but 3x to the 1/2, just like in this example, this is not a whole number, therefore this is not considered a polynomial. Our third example, we have x divided by 2. This is a polynomial, but in the non-example column, our variable is in the denominator. Our last example, it appears that it may not be a polynomial because we have a negative exponent and it's not a whole number. But if we were to simplify this expression, when you have a negative exponent, remember that you reciprocate. And so this is really x to the positive 1. This is why this is considered a polynomial once it is simplified. And then you can see here that we have a negative exponent on our variable, therefore this is not an example. Let's start talking about how we can classify polynomials. Remember, we can classify by term and degree. So let's look at terms first. So just remember that terms are separated by addition and subtraction operations. So this expression is a polynomial. I have whole number exponents, and it is a 3-term polynomial. We have 3 terms. In the first term, we have 2 factors, 3 times x squared. So this is one term. This term has 2 factors, 9 and x, 9 times x. And then our last term is a constant. So we have 1, 2, 3 terms in this polynomial. Now let's jot this chart in your notebook. Let's talk about the names of a polynomial when we classify by terms. Remember, nomial means term. So when you use these words, you are classifying by terms. Mono, meaning one, says that this polynomial has one term. And here are 3 examples. 8x squared, negative 3xy to the 4th, and 3x divided by 8. Again, division and multiplication do not separate a term from a term. Then we have binomial, meaning two terms. This first example, we have 2 terms separated by addition. Our second example, the 2 terms are separated by subtraction. Then we have a trinomial, meaning 3 terms. We have 3 terms separated with an addition and a subtraction. 3 terms, 1, 2, 3. Now, when you have more than 3 terms, such as our last example, we have 1, 2, 3, 4 terms, we simply call this a polynomial. You really could call all of these polynomials, but we do have specific names for a 1-term, 2-term, and 3-term. But when you get more than 3 terms, you really just say this is a polynomial. Now let's talk about a few more definitions. Let's talk about when you are asked to identify the degree of a term. So this is a monomial. It's one term. We have no addition and subtraction. But if I were to ask you what is the degree of this term, you must add the exponents. So we have x squared and y to the first. So this has a degree of 3. So just when you're classifying and I ask, what is the degree of this monomial? You would say as a degree of 3. Now let's talk about the degree of a polynomial. The degree of a polynomial of the whole expression is the highest degree of its terms. So we have 1, 2, 3 terms. So this is a trinomial. But now let's talk about the degree. So we can see that this term has a degree of 4. This term has a degree of 3. And this term has a degree of 2. So we would say that the degree of the entire polynomial is a degree of 4. So now let's take a look at some classifications or terms that we use when classifying by degree. So here we have an example, 2x plus 1. This, it is a binomial, but now we're just talking about the degree. This polynomial has a degree of 1 because the largest exponent on the variable is 1. So we call this a linear polynomial. Here's the second example. There's no variable, but we could add a variable, 21 times x, but we've changed the problem. However, if we say 21 times x to the 0, we really just have the original problem because anything raised to the 0 power is 1, so x to the 0 is 1. 1 times 21 is 21, my original problem. So I've not changed the value. I'm just showing you why this is a degree of 0. So anytime you have just a simple constant or you have the exponent is 1 on your variable, you call it linear. Now let's go to a quadratic polynomial. Quadratic meaning a degree of 2. Our example, we have this trinomial, but we're classifying by degree, so we look at the largest exponent on the variable, and it's a 2, so I'm going to identify this polynomial as a quadratic. So this is a quadratic trinomial. Then we have a degree of 3 called a cubic. My largest exponent is 3. So we have a 3-termed polynomial called a trinomial with a degree of 3. So we call it a cubic trinomial. Quartic, our highest exponent on the variable is 4. Quartic meaning 4. So this is a trinomial by terms, but it's a quartic by degree. Then we have quintic, meaning 5, and our highest variable is 5. So this again is a trinomial, but it's quintic in degree, a degree of 5. Let's talk about 2 more vocab terms. Standard form. Standard form is when you have a polynomial where all the like terms are combined, and then the terms are arranged from the greatest to the least by degree. So let's look at this example. It looks like it has 4 terms, but really we need to combine like terms first. So I'm going to combine negative 1x and 4x. So first we make sure that all terms are combined. Now we need to rearrange them. So this negative 5x squared term comes out front. Then we have the linear term, and then we have our constant. So from the greatest to the least. And always, always write your polynomials in standard form. Now let's talk about the word leading coefficient. Coefficient is just your numerical factor with your variable. So it's your number that's attached by multiplication or division to your variable. So this is in standard form, and the coefficient of my largest term is -5. It's leading, it's out front, so my leading coefficient is -5. Now, pause the video, jot these examples down, and you are going to write them in standard form, identify the leading coefficient, and classify by term and degree. When we come back, we will go over these. Okay, number 1. Is there anything to combine here? Nope, no like terms. So now we're going to rearrange and we're going to put it in standard form, -4x to the third plus 6x squared plus 7x minus 1. Now let's identify the leading coefficient. The leading coefficient is -4. And now classify by term and degree. So how many terms do we have? We have 1, 2, 3, 4. So when you have more than 3 terms, we just call it a polynomial. And then my highest degree is a 3. So that is a cubic polynomial. Number 2, nothing to combine, no like terms. We're going to bring the quadratic term out front. Our linear term is next, and then our constant is last. Our leading coefficient is -1. We have 3 terms, so it's a trinomial with a degree of 2, so that's quadratic. So this is a quadratic trinomial. Remember, nomial means terms, 1, 2, 3 terms. Okay, here we have 2 terms. We have nothing to combine. It's already in standard form. So my leading coefficient is the understood 1. Now, we have 2 terms, so we know it's a binomial. However, the degree of this term of my leading coefficient is 3, and the degree on my sec term is 2. So we're not really going to call this a cubic. We're just going to say that it has a degree of 2. I'm so sorry, a degree of 3, and it is a binomial. So you may want to write it in the opposite way, a binomial with a degree of 3. So let's fix this. I think it sounds better when we say a binomial with a degree of 3. And then our last one, we have a trinomial because nothing can be combined, but this quadratic term needs to be moved in front of my linear. So we have -4x to the fourth plus 3x squared minus 6x. My leading coefficient is -4. We have 3 terms, so it's a trinomial. We have a degree of 4, so it's a quartic. So we have a quartic trinomial.